But first, I'm not a statistician, and I have to say that maybe I'm politically incorrect, but I hate statistics. This is my, and I think some of you may share this. For a variety of reasons, I think when you need a very complicated statistic to show something, sometimes I have many doubts. Anyway, let me give just some impression. In the last year, we saw the burning of a new category of people which are called the trialists, for which the statistics become the religion. And we have the trialists which are the Taliban of this religion, which are spread between Canada and Australia. And having that, the way of thinking, if I have 2 billion of patients, I will find the truth. So in this line, we have more and more patients, more and more complicated statistics, etc., etc. This is one line of thinking that is within the air we are breathing now. In the opposite side, if you go, I mean, an example that touched me a little bit, to chest, 1975. Samuel Permo described one patient with all the catheters in the pulmonary artery, in the pleural space, in which a methacholine was done to increase the resistances. Okay, if you read this paper, all what you have to know about heart and lung interaction, pleural pressure, esophageal pressure, changes in hemodynamics, central and peripheral, is written there. So I think, first we have to think one, I see the reality in two spaces. One is to understand the mechanism, and this is physiology, with these experiments. And the other side, there are these big studies to prove that something is effective. But let me go through through this one. I think one of the best examples of statistics which become gold is the driving pressure. The driving pressure is based on one equation. This is tidal volume times the compliance is equal to pressure. Whatever you do, this is the relationship. All the studies were done using the change in tidal volume as a primary, as independent variables. And the driving pressure was the dependent variables. The mediation statistics, which is a beautiful example of statistics, described in 3 pages, because it's very complicated, never used before in our field or in medical field, allow to transform this and to produce some beautiful graph. But doesn't change what we know. This paper was around about 10 years. But back, forget about the medicine just a little bit. In all our, let's see, Western culture, we wanted to reach the truth. And along this line, we have patients say, well, you never reach the truth. And other currents say, okay, you can reach the truth. How? Through the sense experience or through the mind. And these are philosophic currents. And which is the object? Is innate or is external? And we have deduction and induction. Deduction from general to particular, the induction from particular to general, law and theory. So how all this apply to our field? I think that this, to me, is a key point when I read or when I approach whatever scientific problem, or particularly when I have the randomized trial. In science, in general, first, We have in inductive reasoning, we observe this phenomenon, this phenomenon, this phenomenon. We try to find a similarity, and we generate a general law. And this is back to Aristotle. It's not very recent. This is the way our mind usually works. We try to extrapolate from single observation and general theory. Now, this general theory, what is in our scientific literature? Is what is written in background. Now try to read the background according to this view, which is true, the true view, because from this theory we derived one hypothesis. As an example, the theory is that multi-organ insufficiency comes from an imbalance between oxygen supply and oxygen consumption. This is one theory which is derived from many observations. Now, from this theory, if this is true, if I correct the imbalance, I will decrease the multi-organ failure. And if I decrease the multi-organ failure, maybe I increase the mortality. So this is the hypothesis. Remember always, the hypothesis is written inside the theory. It's not something which comes elsewhere. If come elsewhere, there is no any logic in this course. So we have the hypothesis, and then we do the experiment. And this hypothesis, until here, we arrive to Aristotle up to Descartes, to 600, through all the scholastic philosophy. Then in the 17th centuries, it comes out from here. Okay, the hypothesis is a good thing, but we have to prove with an experiment. And the experimental view was you start with Galileo. And Newton, who born the same day, or the same year, when Galileo died, developed again at the maximum this experimental part. At the point that when Newton, at the end of his life, tried to prove the gravitational theory with the experiment, he failed. And he concluded the experimental gravitational theory was wrong. This tells you that there's some intrinsic risk in experiment. The experiment has to be designed in a proper way. The little statistics is just the little end point of all this process in this particular, not only in the RCT, which judge how the results of the experiment may be or may not be consistent. This is not the religion. And then when we do an experiment, what we prove, and we come to Popper. So the big to me is Aristotle, Descartes, Galileo, Newton, Popper. These are the big step of the epistemology. And what say Popper? You see the last picture when a black swan. Popper say, okay, what is the general theory? All my observation, all my are white. But it's enough to find one black that this disprove. So you have to go back and to discuss the theory, the observation, to discuss the hypothesis, the experiment. Each of these steps may be wrong. The statistic is just a little part of all this. Unfortunately, we spend a lot of time maybe in discussing the result and the values of P00, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 While first we should spend a lot of time to justify the theory. Is the theory really correct? Is the hypothesis biologically plausible or not? This is the way that I personally think we should read it. So, as an example, theory, proximal intracranial arterial occlusion causes brain tissue ischemia reversible within these 6 hours. This comes from some observation. The hypothesis, if I reperfuse, maybe the things are better. They did experiments and everything worked very well. We may ask yourself, okay, is it necessary to do the experiment for that? But this is another question. This morning I wake up and I read the New England JAMA Electronic. Great study. Meta-analysis, 27,000, 22,000 patients with coronary risk, at risk of coronary. And the patients were measured the troponin. Maybe you cannot believe, but the patient with troponin, high-sensitive troponin, lower than 5 nanograms per milliliter, have a less chance of having myocardial infarction. Now tell me, what sense makes this kind of study? This is one example of the absolutely idiot theory, the absolutely inconsistent hypothesis. No, the theory was idiot, so the hypothesis follows to be idiot. But let's see, let me give you some example. Extracorporeal support. No? The premises of extracorporeal support, the patient said, why I connect the patient to the extracorporeal support in RDS? In a 74. When the study was done, it was thought in the 70s or late 69, late 60s. The premises at the time were not to change the mechanical ventilation, to change the pressure, to change whatever. The premise was very clear. First, the respiratory support must provide normal PO2 and PCO2. This was what believed at that time. Okay? That the good stay is linked to this. Second, that the high FiO2 is harmful for the lung. The devil of the mechanical ventilation was the FiO2. Now it's coming back slowly after 30 years of silence, after it disappeared. So what they did, if these are the premises, the hypothesis, if I provide blood gases through artificial lung, reducing the FiO2 in the normal lung, I will improve the survival, which is perfectly logical, okay? So they did the experiment. And the experiment, no big mortality, lot of problems, but the experiment clearly showed that the hypothesis was wrong. That means the theory back was or incomplete or wrong. That's it. But reading this paper, the people say, extracorporeal support, scheisse, throw away. And for 30 years, nobody used. Now, a lot of people use extracorporeal support with the same evidence we had 35 years ago, close to zero, in terms of randomized trial. The poor Caesar stay for 10 years, one patient more, one patient less, very strange design, back and forth the major journal. I know the story of this. But everybody which has in the hand an artificial lung knows how powerful is this instrument to control certain situations. So, the common premise is wrong, as normal blood gases are unnecessary for survival. But this was learned over the years, not at the time. Now, at the time, PCO2 had to be 40. That means the tidal volume sometimes was greater than 1 liter. The pressure were up to 100. Premises second, other factors other than FiO2 may damage the lung. The interpretation was a disaster. I versus low tidal volume. Great. You know the story of this study. You say, what do you think? You know that 6 is the paradise and 12 is the hell, right? First, anytime you look at the mortality difference, it's not as if I use 12, I kill all the patients in which I use 12. I probably damage more a little cohort of patients, which are likely to be the more fragile, compared to use a more gentle ventilation. First, this means the difference of mortality of 2-3%, in this case was about 7-8%. But 12 milliliters instead of 6. And you know that 12 was decided after a phone call to a friend of mine from NIH because the original was 10 or 8 versus 6. And my friend over the night, I don't tell you the name, but he stayed JJ, he said, well, why don't you use a larger signal? Use 12 versus 6. It would have been 10 as all the randomized study before. All the story of atelectrama, hypervolemia, blah, blah, would not exist. Because this was a bad for the, very likely, for the hiker harm. Was simply to hike. But remember, when a randomized trial is negative, so-called, you have 2,000 possibility to discuss the results. When it's positive, I think the signal is extremely strong. This is why, as an example, I agree with the story of the PROE study. PROE study, I think, showed excellent result in some category of patients. Then was done another study, negative. So why not to do the third? But for economic reason, for other reason that nothing has to do with medicine, this was not done. And this is one of the intrinsic risks of the study we are doing. You will see, I think in the near future will appear the results of the Eolia trial on extracorporeal support. Very severe patient in which the mortality rate to become the magic 0.05, the absolute decrease in mortality, absolute decrease, is 20%. What means? Means that the ventilation with 6 milliliters of total volume as done in the control we do, we kill 20% of the patient with severe ARDS of that decrease. And it also means that the extracorporeal had a number of complications of that equal to 0. Is that possible? No. The study will be a failure, and of course the people will say, well, the extracorporeal support is not, go to the administrator. Are you crazy to spend this money for? But because the design of the study is wrong, because the power is not calculated on a reasonable assumption, this I can expect how much? 5 to 7, 8% differences in the most optimistic view, not 20. But to have 8% of difference, I have to use 2,000 patients. To collect 2,000 patients in extracorporeal circulation with the rate of enrollment we have in this study, it takes between 15 and 20 years if we have 40 units participating. And then I see in the podium people speaking about the science of the randomized trial. Please, take a breath and think at all the sequence and the feasibility of this. This is the tidal volume. Tidal volume, as an example, okay. The PEEP trials. We have, what is the hypothesis of the PEEP trial? that some level of PEEP is necessary for oxygenation. Everybody uses PEEP for oxygenate, basically. But in the last 20 years, after the editorial of Lachman, keep the lung open, and after studies on isolated rat lungs by Slasky and Tremblay and my friend Valenza, all the story of the atelectrauma took the place, right? The atelectrauma for years is the devil. What is the most worst possible scenario for the lung? Is opening and closing. Now, here we have in these PEEP trials, the adverse effect of higher PEEP over this patient are inferior to his beneficial effects, prevention of damage induced by intratidal collapse. Okay? These are the premises. And the deductive hypothesis, if this is true, higher PEEP improves survival. It's very simple. We did a lot of study about this. Then you can play with the sub-analysis of, this is my cousin, I have to go in the group A, no, my group B2, X, and so and so and so. But the results are very clear. There is no signal, strong signal, to justify the premises. Means that the premises are wrong. How many thousands of experiments have been done on sepsis, blocking the inflammatory reaction? On which are based? That sepsis is an overwhelming reaction of inflammatory reaction to an infection, as an example, right? We did 1,000 experiments blocking the inflammatory reaction, nothing happened. What means? The population is not homogeneous, the time is wrong, the blah, blah, blah. No. Means simply that the theory is wrong or is incomplete. And we are very reluctant to accept this simple truth. In these experiments, tell you clearly that within the limits in which the PEEP was tested, atelectrauma is not worse than a possible volutrauma. Volutrauma is here, and more atelectrauma is here. And now, pach, we have even higher PEEP. And this clearly shows that in control, when the PEEP greater than 16, 17, look at the standard deviation, up to 20, the risk of using high PEEP is greater, the risk of volutrauma, than the risk of atelectrauma. And that means that for 20 years, we overestimate the risk of atelectrauma. Everybody married his own idea and loved his own idea. But I think we should have the intellectual strength to recognize when the facts are in contrast. Even if you hear in the congresses, in the lessons, sometimes in the book, continue to repeat past and copy, past and copy, past and copy, the same concept. These are the facts. Then you can play with the number as you like. The statistics just tell you that, okay, this is what you are doing. So, in a general population, PEEP 7 to 15, atelectrauma, whatever it is, at PEEP greater than 15 is wrong. That means in the overall concept, pay more attention to volutrauma than to atelectrauma. Don't become paranoid in keep lung opening. Because you kill the patient, recruit maneuver, 60 centimeters of water, 80, 200, but doesn't mean any sense. Promposition. Promposition, I think, is a good example of understanding the mechanism, trial, and try to prove that the mechanisms are good or not, are consistent. Because when we start the first two trials, we start saying, okay, why the prone position should work? Because it provides better oxygenation. Better oxygenation is probably linked to better survival. This was what believed at the time. Was the observation, the usual observation is the patient with good oxygenation die less than the patient with worse oxygenation. So it's an absolutely common sense hypothesis. But in this trial, we found that we increased the oxygenation, but the mortality was exactly the same. Then Marsibo, from the Marsibo, said, well, change the premises. No, wait a second. Prone position is good for oxygenation, but the prone position just make the lung far more resistant to the insult because it makes the distribution of forces more homogeneous. Each part of the lung takes its own load. It's not concentrated in one part of the lung as in supine position. Okay? And this trial, Mancebo failed because the number, he had to interrupt the trial. We did the trial exactly with the Mancebo and specifying before the trial to the authorities, we at the end, we will join our severe patient because a rolling problem. Join with the Mancebo trial, our trial with Taccone was clearly showed that in more severe patient, in which the prone position, the homogeneity plays a major role, benefit of prone position. And at the end, it come out, these are the general population, clearly nothing happened, but these are the patient very severe, our data plus Mancebo data. And this is the Guerin trial. The overall mortality is better, but the difference between the two groups is quite similar. And there is no question. Prone position can benefit one patient over 10, 13, 15 patients may survive because the mechanical ventilation is less dangerous in prone than in supine. But the patient has to be severe, has to have the logical, biological premises for the prone position to work. If I don't have, as in a mild ARDS, any collapse or very low collapse, I use prone position for what? Just to torture the nurses and to oblige a great sedation and so on. So the benefits do not exist. Okay? So, and then very rapidly I finish because I can go ahead for a lot of time. The statin in ARDS. I read the title and say, no, wait. Maybe I just wake up and let go to wash my head. The title is, why should Simvastatin improve ARDS? Which is an invention, it's something that we invented. We pretend to find one magic pill which cure a disease, which is not a disease, it's a syndrome that we invented. But where is the logic? What is the biological plausibility? If you give the aspirin, it's better. We know that we give tons of cortisone. Nothing changed, and I had to use the pro-inflammatory virtue of the Simvastatin. This is the RDS. Oh, well, let's see. So, the other one, 65. My friend, my friend, when I read, somebody said that 65 is good. Well, everybody, I go to take a beer, do one beautiful. What is your pressure? Well, 65 millimeter pressure is not bad. You are 70. Okay. So the hypothesis, but this is not biological hypothesis, it's a bar hypothesis. Lower or greater pressure may be good. Why not? And then I do the experiment. Great. What's happened? What's happened? Now, well, I went to see in our patient, take one database and look at the mineral weight pressure at entry. And you see 65 and 75 map between 70 and 100 is here. You play your trial around here. What sense makes? If we say, okay, I compare 40, 240, or 40 to this, or this to this, may have some sense. But it's an ideal trial anyway, because I don't compare a patient and randomize a patient with 20 of mean airway pressure to be randomized to 40. I randomize cadaver to cadaver. Okay? But this just tell you that while we spend hours, days, and months of discussion in designing the trial, the details of the trial, we maybe spend 10 minutes in one afternoon at the beer, with a beer in front, to discuss the theory and the hypothesis. Just discarding all our centuries of thinking on epistemology, which is a complicated word to see the philosophy on which science is based. That means our brain afford the problem to find the truth. So of course this was the MAP study, and RCT, deductive method, my work only theories, assumptions, and premises are strong and probably correct. And this rarely happens in ICU. And whenever other input you have to do a trial, and I'm afraid the economic pressures sometimes are a real driving force behind many of the trials that we read on the paper, are, I think, unavoidably associated to a bad medicine. I thank you for the attention.